So this is the question. At a 45 degree centigrade, the ionic product of water is a 4 into 10 power minus 14. Calculate the pH of neutral aqueous solution at 45 degree centigrade. See, Kw, this is called the ionic product of water, which is equal to the H plus ion concentration multiplied by OH minus ion concentration. So when the water is getting dissociated, the concentration of H plus ion concentration and the concentration of OH minus ion, they are supposed to be equal, because when one H plus comes out, one OH minus will also come out. So if you take the square root of Kw, you will get the concentration of H plus or OH minus, both are equal. So the square root of ionic product of water, 4 into 10 power minus 4 is equal to minus 14 is equal to 2 into 10 power minus 7. So H plus ion concentration at a 45 degree centigrade is 2 into 10 power minus 7. So the pH of any solution is equal to negative logarithm of H plus ion solution, H plus ion concentration. So substituting the value here, it is negative logarithm of 2 into 10 power minus 7. So it is 7 minus 0.3. So it is 6.7. So the pH of water at a 45 degree centigrade having the ionic product of water 4 into 10 power minus 14 is a 6.7, which means that the water is slightly acidic. Water is slightly acidic. What will be the pH? What will be the pH of 0.1 molar ammonium benzoate? Ammonium benzoate. Ammonium benzoate means benzoic acid plus ammonium hydroxide. C6H5COO ammonium benzoate. At 298 Kelvin, the pKa value of benzoic acid is pKa value of benzoic acid C6H5COOH. Benzoic acid is 4.2, and that of ammonium hydroxide is 9.24. Actually, the pKa value is given. I need to know the pKb value. So what is pKb value? pKb value is 14 minus pKa value. So the pKb value of ammonium hydroxide. Why I am taking this pKb value? Because ammonium hydroxide is basic. Benzoic acid is acidic. So Ka is acid dissociation constant. Kb is base dissociation constant. For pH calculation of such problems, I need to know pKa and pKb. So it is 14 minus 9.24. So you will be getting 4.76. So the pH of the solution is pH is equal to half into pKw plus pKa minus pKb. So it is half into 14 plus pKa of the acid is 4.2 minus the pKb of the base is 4.76. So when you do the calculation, you will be getting 6.72. So 6.72 is the pH of ammonium benzoate when the pKa of benzoic acid is 4.2 and that of ammonium hydroxide is 9.24. Another problem is interesting one, the preparation of a buffer. So I make 1 liter solution using 0.12 mole of HCl and 0.36 mole of aniline. You have to find out the pH of the resulting solution. Whereas the pKa of aniline is 4.62. Watch closely. Aniline is, this is aniline. Aniline is a weak base. When aniline is added with hydrochloric acid, you are getting this is salt. So a weak base and it's a salt, when they put together, they form a buffer. But in this case, I'm having 0.12 mole of HCl and 0.36 mole of aniline. So 0.36 mole of aniline, when it reacts with 0.12 mole of HCl, this is actually the limiting factor and this is the excess factor. So the salt that is formed will be 0.12 mole and the molarity of and the mole of number of moles of unreacted aniline excess will be 0.24. So now I'm going to substitute these values in the equation. POH is equal to pKb minus pKb plus log of salt concentration by acid concentration. Sorry, by base concentration. This is called Anderson-Hasselbalch equation. So the POH is equal to pKa is given. You have to find out what is the pKb. pKb value is 14 minus 4.62. You will be getting 9.38. So the pKb value is 9.38 plus log of salt concentration is 0.12 mole and the base concentration is 0.24 mole. Because why directly number of moles is substituted here? Both of them are present in 1 liter solution. Therefore, the concentration is not going to change. So it is 0.14 divided by 0.12. So if you simplify, you will be getting 9.38 minus 0.3. So the POH of this solution is 9.08. If a POH is 9.08, what is the pH of the solution? Because what is asked is a pH. It is 14 minus 9.08. So the pH of the solution is 4.92. So here you have to understand one thing. pKa plus pKb is equal to pKw, which is equal to 14. pH plus POH is equal to 14. H plus multiplied by concentration of OH minus will be 10 power minus 14. These are all the important idea you should know. I'm taking 4 different substances. One is ammonium chloride, and the other one is potassium carbonate, and the other one is potassium cyanide, and the other one is a sodium sulfate. The question is, if you add these 4 substances in 4 beakers with water, in which beaker the pH of the water remains the same? The neutrality of the water is not changed. So you look at the substance. The first substance is the combination of ammonium hydroxide and hydrochloric acid. The second substance is the combination of potassium hydroxide plus H2CO3 carbonic acid. Third one is potassium hydroxide plus HCl, hydrocyanic acid. And the third one is sodium hydroxide plus sulfuric acid. So if you take here, this is strong, this is weak. Here it is strong, it is weak. It is strong, it is weak. But in the last case, sodium hydroxide is also a strong electrolyte, and the sulfuric acid is also a strong electrolyte. When two strong electrolytes, one acid and one base, combine, they will give a salt called neutral salt. So on the addition of neutral salt, the pH of the solution will not change. Whereas in all other cases, depending upon the nature of the salt or the nature of the base or the acid, the pH of the pure water will change. But when you add neutral salts such as sodium chloride, sodium sulfate, or potassium chloride, potassium sulfate, or any other strong salts like this, the pH of the solution will not change. Clear? What volume of water must be added? What volume of water must be added to 1 liter of a solution of acetic acid? 1 liter of solution of acetic acid. I am taking 1 liter acetic acid and I am going to add sufficient amount of water to make the hydroxide ion concentration 3 times. I want to increase the concentration of hydroxide ions 3 times. See, I have acetic acid and it is 1000 ml. When you dilute, acetic acid is a weak acid. Acetic acid, when it combines with water, it becomes acetate ion and hydrogen ion. Along with that, OH minus ion is produced. So when dilution increases, when I go on adding the water, more and more acetate ions are formed and more OH minus ions are also formed. The concentration of H plus is equal to square root of Ka into C, the concentration. The question is, I have to increase the OH minus ion concentration 3 times. So if you want to increase 3 times, as the concentration term in square root, I have to dilute it to 9 times because square root of 9 is 3. So the 1 liter of acetic acid has to be diluted to 9 liters by the addition of 8 liter of water. So when you add 8 liter of water, you are diluting the 1 liter acetic acid solution into 9 liter. So the concentration becomes 9 times and the square root of C, root 9, becomes 3. So the OH minus ion concentration increases thrice. Calculate pH of 0.25 molar HCN, hydrocyanic acid, where the Ka of this acid is 4 into 10 power minus 10. You have to calculate the pH. See, the concentration of H plus ion is equal to square root of Ka into C. So the Ka is 4 into 10 power minus 10. The concentration is 0.25. So you take the square root. So this becomes 1 into square root of 1 into 10 power minus 10. So it becomes 10 power minus 5. So the pH is negative logarithm of hydrogen ion concentration, which is 10 power minus 5. So the pH is 5.